Awesome. Thank you, Olia and Luce. I love coming in from the website. It's always new to me, so I can actually go the reverse now that I know the Xamarin part, go to ASP.NET. Now I'm really excited. Two of my favorite individuals in the entire world are here with me. There's a dual presentation to talk about dual screen devices. Craig Dunn and Guy Marin. I'll let them take it away.
Thanks, James. Hi, I'm Craig.
And I'm Guy.
Thanks for joining our presentation today. Let me start. Welcome to our session on developing dual screen experiences with Xamarin. Today, we're going to quickly introduce you to the world of dual screen devices and explain how to get started building dual screen apps using C#, Xamarin, and Visual Studio. Let's start by taking a look at two upcoming dual screen devices from Microsoft, the Surface Neo and the Surface Duo. As you can see, both of these devices have distinctly separate screens, similar to having two monitors on your desktop computer. They're joined by a hinge that allows the screens to fold into different positions. Holding and using them feels a lot different to interacting with just a tablet or a laptop. This creates opportunities for new ways to present information and new ways for people to interact with your apps. Besides the obvious size difference, there's one other thing you should know about them. The Surface Neo runs Windows 10X, and the Surface Duo runs Android. This is fantastic for the breadth of apps available on these platforms, but for some developers, it might present a challenge. How can we build apps that work on both these devices when they run completely different operating systems? It's a trick question, of course. Everyone watching knows the answer is Xamarin. With Xamarin.Forms, we can build cross-platform apps that target UWP and Android, so we can support both devices, regardless of operating system or number of screens. Let's talk a little about the dual screen user experience and then see how Xamarin.Forms makes it easy to build apps that take advantage of them. Here, you can see the Surface Duo being held in a book-like position. This is the key selling point of dual screen. They expand the capabilities of our devices in a natural way. Existing apps are definitely supported. Devices can fold into what we call flip mode, where they only show one screen and behave just like any other mobile device. When unfolded, existing apps continue to just work, except now they can run side by side, one per screen. Comparing and sharing data all becomes easier, especially with drag and drop. But the best experience occurs when apps are expanded and optimized for both screens. They can now offer new ways of presenting information and new ways for the user to interact with it. What might these interactions look like? Here's a summary of the different postures the devices can be placed in. The first row is similar to existing devices, a single screen in portrait or landscape orientation. Note that the Surface Neo has a unique landscape orientation with its hardware keyboard applied and the Wonderbar visible. But when the devices are unfolded and using both screens, they enable the postures in the second row. In dual portrait or wide mode, it almost feels like you have two phones side by side. Users might prefer to be multitasking in this mode, with two screens being used to separate or compare or to share content. In dual landscape or tall mode, users often want to use the entire area to focus on one task, so the two screens are often used to expand the content area for a single app. When the app is expanded to take up two screens, we say that it has been spanned across the screens. It can be spanned in two orientations, and we say tall and wide to prevent confusion with single screen layouts. One last piece of terminology. We call the space between the two screens the seam or hinge. On the Surface Duo device, the seam represents pixels that aren't drawn, so app content can be hidden behind it. On the Surface Neo, the seam has zero width, so that's a difference to be aware of. We have a custom control available to help you take this into account automatically, but we'll cover that shortly. These 5 common UI patterns are able to help you tailor your app user experience to what they're trying to accomplish. Think of them as a framework to help you think about the ways your app can take advantage of dual screen devices. Each of the two screens should have a specific and well-defined purpose in the user's workflow. We don't want to expand to two screens to make apps more confusing or hard to use. We're going to examine each of these in more detail and then look at the Xamarin.Forms, XAML, and C# to implement them. Extend Canvas is very simple. An app's view resizes to take up the additional screen. While it's the simplest dual screen pattern, it's still powerful and a great way for some types of visual data to be consumed. You might consider this pattern if your app has a free-flowing canvas where the user is able to scroll around under the seam, or if you need a bigger canvas for tasks such as drawing. Excel sheets, maps, and drawing apps are all good candidates for this pattern. Master detail is already a common pattern in mobile and desktop apps. There is a master pane, usually with a list view, and a details pane with more content. When an item in the master list is selected, the corresponding details are displayed. The list could be text or images or anything really. In this view, it's important to consider what happens when the device is rotated into dual landscape mode. Users often intend to focus on the detail content with that posture, so consider hiding the master list. Examples of apps that suit this style include email, to-do lists, photo browsing, and other data structures where the user might drill down to individual items in a list. In tool mode, email or photo apps would typically hide the list view and use both screens as a scrollable view of the detail item, say your individual email message or a photo that you want to look at. The next one, two-page, is for apps that work with a book-like navigation, so scrolling back and forth between pages. You can use the division created by the seam and the book-like posture of the devices to create a natural feeling where people can move between pages, like text or pictures, in a scrolling fashion. E-readers are an obvious application for this pattern, but it can also be used for content creation, such as a notes app or a drawing tool, where the data is entered but conceptually navigated like a book. Dual view is subtly different to master detail. In this case, the two screens provide a way to compare or to contrast versions of the same content side by side, like two images, two lists, or two documents. Alternatively, you can provide different perspectives on the same data. An example of the first case might be a markdown document showing source editing on one side and a preview rendering on the other. An example of the second style might be a restaurant booking app where a map with markers could appear on one screen and the same list of restaurants on the other screen. It's conceptually the same data, but you've provided two different views for the user to manipulate, letting them dynamically choose how they want to interact with the content. A key element of the dual view is keeping them synchronized to reflect changes as the user interacts with them. And last but not least, the companion pane. Companion pane lends itself to exposing otherwise hidden UI that wouldn't be easily accessible with a single screen. For instance, show complementary context to augment the task the user was working on by elevating buried functionality for quicker access. The functionality should still be available in single screen mode, but it might be hidden by menus or buttons or other multi-steps. An example is creative tools like an image drawing app, which could be placing the canvas on one screen and using the other to hold the brightness and contrast and filtering tools. Another example is gaming. Single screen devices often have the controls overlaid on the game viewport, but a second screen allows for dedicated controls without obscuring the graphics. That's all the patterns, but before we get into demos, here's a few simple do's and don'ts for dual screen layouts. Firstly, avoid positioning app elements under the seam, especially when presenting actions the user needs to take. The operating system will attempt to do this for system dialogues, but you should manage your app layouts with this in mind. Also, avoid spreading lists of options, menus, or command palettes across both screens. Choose which screen to display these options so that the user can see relevant information on the other screen. Similarly, be mindful of where the keyboard appears when entering text. Take advantage of both screens to keep the customer in their flow. If the device is rotated while the app is spanned, make sure to move UI elements to a logical position in the new layout. Choose a location that makes the most sense for what the user is trying to accomplish. And finally, look for opportunities to use the UI patterns we just discussed to group or represent content using the seam as a boundary. So given these layout ideas and tips, what have we done to make it easy for you as .NET developers to take advantage of dual screens? Xamarin can help developers target dual screen applications and devices in a couple of ways. The first is the most obvious. It's cross-platform. Xamarin already runs on Android and UWP for Windows 10X, so you can build your app once and deploy it to both styles of dual-screen device. The second way we can help is with a set of methods that provide information about the device. Is the app spanned across two screens? What are the coordinates of the seam? Does my app need to detect changes in the hinge angle? All of this information is available in a NuGet that you can use to do the calculations to lay out your own views to take advantage of dual screen devices. And the third way we can help is with layout controls that will automatically help place the content on one screen or two screens while still being configurable and letting you override the behavior. All this is available now with Xamarin.Forms. You can add the Xamarin.Forms dual screen preview NuGet to your apps today to start playing with these APIs. Here's a closer look at the dual screen info class. Spanning bounds gives you rectangles for each screen that the app is visible on. Only one rectangle on regular devices or if the app is a single screen, but two if it's spanned. Hinge bounds is the opposite. It gives you the area of pixels hidden by the seam. As I mentioned earlier, the Surface Duo and Surface Neo handle this differently, but if you code against the values from this API, you shouldn't have any issues. Is landscape returns dual screen aware landscape status. And span mode tells you the state of the app, whether it's on just one screen or if it's on two screens in tall or wide mode. There's an event, property changed, which will let you listen to changes to any of these values so that you can adjust your layouts manually. And finally, Get Hinge Angle Async lets you query the angle between the two screens for innovative user experiences that revolve around how the user is opening or closing the device. The second item is the new layout control, two-pane view. Here you can see the most simple XAML for two-pane view. At the moment, it supports content views as its children. So here you can map a search videos view and a browse videos view side by side on a screen. On a single screen device, they'll still be side by side. On a dual screen device, when they're spanned, they'll appear either side of the seam. If you want to change that behavior, the two-pane view has a number of additional configuration options. The first four bolded attributes apply no matter whether there is one screen or two. They can be used to force different layouts in tall and wide mode. For example, have one pane take up the entire two screens in tall, but not in wide mode. The last four options are only applied on single screens. They help the layout reason about what to do with the two views when only one screen is available. Recall that the tall and wide modes we referred to are the dual portrait and dual landscape positions that we mentioned earlier. In wide mode, the two screens are actually both in portrait. It takes a bit of getting used to thinking about the differences. The controls measurements are based on a grid, so the length values are relative and can be specified with 1 star, 2 star, etc. You don't need to specify exact pixels, which is helpful when scaling up from a Duo to a Neo or even to desktop apps. I've shown most of the properties as data binding here, but of course you can also set them directly in your code behind. Let's jump over to the emulators and Visual Studio and see these patterns in action in the Xamarin.Forms dual screen sample. There's Xamarin.Forms. So before we start looking at the code, for everyone that's just getting started with dual screen devices, there are two emulators. They're both available in the start menu after you installed them. So Surface Duo emulator. Yep. Oh, thanks for that tip. Got it. Now let's go to Visual Studio. Thanks, James. So let's try that again. When you install the emulators, they both appear in the Start menu. So the Surface Duo emulator for Windows and the Microsoft emulator, which contains the Windows 10X. Oh, shoot. Tell me now. Okay, let's see the Start menu and Surface Duo emulator and the Microsoft emulator. So here we have Windows 10X, dual screen emulator, and here we have the Android emulator. When you first install them, they won't automatically show up in Windows, in Visual Studio as a deployment target, but once they're started, the Android emulator will show up for deployment, and the Windows 10X emulator can be installed in Visual Studio via its control panel, so you can easily get your apps deploying on both of them. If we have a look at the devices, other than the two screens, they have some other similarities. When we start an app, it opens in the screen that we started it in. We can move the app from screen to screen, and to cause a spanning to occur, you just wait for the ghost image to appear across both screens, and the 10X takes a bit longer, but the app will span, and then we can move it back to a single screen, and we can cause rotation, and we can span again. And you've just seen some of the layouts that occur with the dual screen view. So these are the two emulators. Let's actually dive in and see some demos. I want to start with some of the patterns that we just looked at, beginning with, I guess, the simplest one, Extend Canvas. While it's the simplest pattern, it's still useful for things like maps, and it's kind of easy to build because if your app already supports resizing, it's probably going to do just fine spanned across two screens. So here it goes, spanned. And here's a lesson about the do's and don'ts. Here, the seam covers up the placemark that we entered. So an update that you might want to do to this application would be, when you're in spanned, maybe move the placemark a bit to one of the screens rather than leave it in the center. Let's skip back to Visual Studio and see how that works. So Visual Studio dual screen demos. First thing to note, the dual screen NuGet is installed, and a tip before we start, that in your Android main activity, remember to call init. So for those of you that are going to go and get started with dual screen apps right after this, install the NuGet, add the init, and you're ready to go. The Extend Canvas XAML is extremely simple. Turns out it's just a content page containing a grid. And there's really nothing in the code behind either. So you can actually build apps that are going to work well in spanned mode on dual screen devices without really taking advantage of any of the additional functionality that we're offering. But it's really just a baseline or a starting point. And like I said, if you wanted to move the marker a bit to the left, you'd want to include some of our APIs to help you do that. A good example of that is the two-page view. So the two-page view, if you recall, is the one that feels like a book. So in wide mode, you have 2 pages, and if I go back to a single, we have 1 page, which is great. But you'll recall also, I mentioned it's kind of nice when you're in tall mode to use the entire area to consume a piece of content. So in tall mode, if I span and go into two-page view, you can see the navigation has changed. It's scrolling up and down, and the entire page is taking up both screens. So that's a nice adaptation to how the users might want to use this style of interaction. If we go and look at the code, so here's two-page view XAML, you'll see once again, actually it's just a grid, and within that a collection view. And we're taking advantage of the collection view's ability to be super flexible. So we have a linear item layout that's just laying things out, scrolling left to right. It's an horizontal orientation. And you'll notice though that for the item spacing, the binding is to hinge width. So this has got a really neat trick where it's just using regular features of Xamarin.Forms, linear layout of an item of a collection view, and the spacing of the pages is the width of the hinge, so it automatically is going to avoid that seam area as the pages are rendering and scrolling. So if we look a bit further down at the actual page sizing, you'll see that that's also a binding to content width and content height. And those two values are also being driven by the dual screen info SDK, even though we're using regular Xamarin.Forms controls, where dual screen enabling them by linking them to properties from the helper class. So here we are in the code behind. The list is just 1,000 pages, so there's nothing special there. We wire up the property change events, but the really interesting thing, like we said, content height and content width are properties that are bound in the XAML. But here's where the magic happens. We have the panel heights and the hinge width all being set from the dual screen layout info class for different properties. So we're looking for the spanning bounds for the heights for panel 1 and 2. And you recall I mentioned the spanning bounds are the two rectangles that this method returns if the application is spanned across two screens. And you'll notice that if it is spanned, they both get height 0 and height 1 because those two rectangles exist. If the spanning is false, the first one gets its height, but the second one is 0 because when we're not spanned, we're only showing one page. So we effectively collapse the second pane and it's not displayed. And the hinge width is similarly using dual screen layout info and defaulting to 0 if it's not there. So that actually takes care of if this is going to be on the Surface Neo as well. The hinge width for that device is 0. So it's a neat way to take advantage of dual screen info properties from the device and using traditional Xamarin.Forms controls to create a two-screen aware layout. So let's go back. And the next one is probably the most popular layout, and that is master detail. So it looks exactly like you'd expect on a dual screen device, a list on the left and detail on the right. If we take it down to a single screen, notice that when I click, the second screen animates in. It's really behaving like a master detail with back gestures working to take us back to the previous screen. So let's take a look at how that's implemented because there's a little bit more to it. Here in the master detail screen, it's a pretty vanilla implementation of two-pane view. We've got a master page and a details page within the two panes. And we're using the min wide mode and min tall mode properties to basically force single view to only show the master page. So the master page itself is a collection view, nothing special there, pure Xamarin.Forms. For the details view, again, it's just a regular Xamarin view. It's got a grid and some labels and so on. But because we're using the detail in two different ways, here we're opening it in a new content page to get that navigation style. And when it's spanned, we're just updating a pane in our two-pane view. So in addition to the detailed view, we create a details view container page, which is the one that we can use to pop it open when we're on a single screen. And if you look at the master detail code, I'm skipping through a lot of vanilla Xamarin.Forms code that you all know and love, and just trying to look for where you can see dual screen info is being taken advantage of to enable the dual screen behavior on these controls. So you'll notice here, if it's testing for landscape, it's testing for spanned, setting the binding context for the data, and if it's not spanned and it hasn't already been pushed, we're using the standard Xamarin.Forms navigation to push the details page onto the navigation stack rather than using the side-by-side. So if you're interested in implementing master detail, this pattern in combination with the current version of the two-pane view is going to be very helpful. Now, I'm not going to dive into the other two because they're very similar to master detail. I want to jump straight over to the two-pane view playground. This is the sample that I would recommend everyone go straight to when they start using two-pane view to kind of understand the kind of options and functionality that it provides. So I mentioned earlier the heights and the lengths. They're only really important when you're in a single pane. And you'll notice if I increase the length of this one and decrease the length of that one, I can make it disappear. If I span, sometimes the mouse makes this tricky. Oops. Oh, there we go. Got it. There we go. I can, those lengths make no effect because it's spanned across the two screens. We know where the panes are going to be, but we can change the layout. So we're in wide mode. So we can affect wide mode for configuration by setting it to single pane, which pops the screen across, or we can choose right left, which switches them back and forth. So this is a really neat way of just interactively exploring those properties on the two-pane view that I showed earlier in the slides to let you get a sense of how you can achieve the layout you want that works for single screens, it works for dual screens, and best represents the user interface that you want your user to have. And before we leave it, I just want to mention there's a hinge angle there. You can test the hinge angle on the emulator. It's bound at the moment for development purposes to the pressure slider. So if you want to have some fun building apps that care about the angle of the hinge, you can do that there too. So that's a quick look at the different levels of integration you can have our new controls. The expanded view just didn't use any Xamarin dual screen specific stuff at all, and the master detail is really heavily based on the two-pane view. And there's levels in between. It's really up to you and what you want to accomplish with your app's user interface. So heading back to the slides, I just quickly took some screenshots of that same layout test on a single screen device and on a larger screen device so that you can see the kinds of things that you can accomplish. So you can very carefully tweak your UI for any screen size and style with a two-pane view control. And no real demo would be complete without a production-looking app. So I think we're running out of time, but I just want to quickly show you Xamarin TV, and I'd encourage you to download this one as well and have a play with it and look at the code. So I don't need to deploy it. It's already installed on the emulator. Maybe we can get it running on Windows 10X as well. Oops, I've ran out my demo lock. It appears. Well, oh wait, here we go. So yes, I've used up my luck. So the Xamarin TV app is a fantastic looking app. I think those emulators have just been running a little bit too long. Oh wait, here we go. There's Maddie. It's using the two-pane view in both single screen and dual screen mode. It's got a really cool ink capability, and it's starting up over here too. Anyway, let's save some time and come and look at the static screenshots. It does a really great job of demonstrating the use of two-pane view with a sophisticated user interface that's 100% MVVM, so that it's driven by a navigation service, data binding, and state triggers, which is a relatively new addition to Xamarin.Forms that makes it really easy to affect your UI and keep state in a really natural way if you're an MVVM developer. So I encourage everyone to take a look at that code. Now, once you're ready to get your apps updated for dual screen devices, we have a couple of steps that we suggest. First, download the emulators that we just looked at and test your app. Use it in single screen mode, both in portrait and landscape, to verify it works well. And then try spanning it across the screens and start to think about how you might enhance that experience. Second, make incremental changes to work better on dual screen devices. You don't have to immediately adopt two-pane view. Some of the other things that I mentioned about tweaking the UI might be enough. Additions like multi-instance, pen input, drag and drop, and other Android features can benefit all your users, but really shine on dual screen devices. And third, using the UI patterns we just talked about and the APIs and layouts provided by Xamarin.Forms, start to implement dual screen specific navigation and interactions that really take advantage of both screens. I hope today's talk, despite the little snafu at the end, has got you starting to think about new ways to engage your customers and take the first step by downloading the developer tools today. Here are some resources. I don't expect you to remember all these links. I bet everyone on the video call today has been to docs.microsoft.com before. So if you can remember docs.microsoft.com/dual screen, you'll be able to find your way to all of the other links here. I don't know, I'll see if we have time for questions, but please reach out to Guy and myself on Twitter. Our links are there at the end. And otherwise, don't forget to use the .NET Conf hashtag when you ask your questions, and maybe win a Xamarin Monkey.